Visible?
Yeah, it's visible.
Okay. Good afternoon to one and all present, and welcome back to your lab session of your data structure. See, so far we have seen practicals till implementation of stacks. Implementation of stacks using linked list, right? Practical 8. All right, so far we have completed till here. But now, owing to the lab session which is going on right now with B and C batch, I want my A batch also to be with them. Okay, so in yesterday's session, I started with quick sort and bubble sort with them. Okay, which is also the part of your unit number 4. Your unit number 4 is sorting and searching techniques. All right. So in that, there is quick sort, merge sort, bubble sort, selection sort, and insertion sort. Out of these 5 sortings, you have 3 sortings in your practical approach also. That is bubble sort, okay, quick sort, and merge sort. These 3 are also there in your practicals. So that's why I told you that now in the practical session we are going parallel. Right now we are in our theory session, we are covering this your unit number 3. Okay, but because these sorting techniques are there in your practical session also, as well as in your theory unit also, so we are going to go parallel, that in your practical session we will complete the part of your unit 4. Okay, that is quick sort and merge sort and bubble sort. And in our today's session, we are going to see quick sort, okay, and later on we are going to see bubble sort. Why I'm not taking merge sort? The reason is they both are a little bit lengthy to understand. Okay, bubble sort is comparatively shorter, so we can cover quick sort and then we can cover bubble sort. All right. So 2 topics from your unit number 4 will be covered here along with its practical. Okay, that is how I have approached with B and C batch, and that's why with you guys with A batch also I'm applying the same approach. All right, so let's start with your quick sort first. Ever heard about quick sort previously to what we are going to discuss? Ever heard about quick sort? Anyone? Okay, don't look at the screen right now. Ever heard about quick sort? Nobody has heard about quick sort?
Is it that way we make two arrays and we switch their elements side by side?
Correct. Correct. Absolutely right. Anyone
One
else?
array start from j, one array start from 1 and another array start from I plus 1, and we then switch it and we will
Right.
reduce the size of the array till it come to the last element.
Correct. Absolutely right. Anyone else? Not even D2D students. I have D2D students in this batch. You guys have not heard? Okay, Smriti says heard about it. Fine. No problem. Even if you don't remember, it's okay. This will be a revision for you, and for the rest of the students, it was expected that you might have heard about this quick sort from your CP subject, but okay, even if you don't remember or you don't know, then also it's fine. Okay, not a big deal. Quick sort we are going to see today. Now for that we have to understand some theory, the working mechanisms. Okay, see your quick sort, I'll be using the Excel approach. Okay, PPT I'll upload it for you. Fine. So do not worry that madam is not teaching from the PPT right now. I will upload the PPT in your e-content, but right now, because this is a practical session and this is the approach so far we have done with your Excel, it is easier for you to understand. Okay. See, your quick sort works on the principle of divide and conquer. Okay. It works on the principle of divide and conquer. So what you are basically going to do in this particular quick sort, this sorting technique, okay, you are going to sort your array ideally in ascending order using the principle of divide and conquer. Now what you are dividing here, the very first question, answer to that is you are dividing that array, the given array. Suppose this is your given array, okay, and this is the end result which you want. This green part is the end result which you want. If you can observe, this green portion array elements are arranged in ascending order: 1 2 5 6 7 7 9 10 and 15. Okay, so this is my end result which I want. This is my given array from the user. The user has input some array elements, okay, of 0 to n minus 1 range, and they are randomly in given input elements. All right, my aim is to sort this array using quick sort. So quick sort works on the principle of divide and conquer. Now here what we are dividing this array, okay, in such a manner, that we get two sub arrays and one pivot element. Here there is a concept of pivot element. Pivot element is nothing but your key element. Okay, this key element at the end of one swap, there will be many swaps. Okay, because you are dividing into left sub array, right sub array, then you are again swapping your elements in order to rearrange them. Okay, at the end of one swap, this key element, okay, will be at its appropriate position in your sorted array. Okay, so that is what you are conquering. You are identifying the appropriate place for your key, or say for your pivot element. Now this, how you are going to choose this pivot element? The second question. See, out of this given array, okay, out of this given entire array, you can select your pivot element as any element of your choice. Okay, you can select this first element. Okay, you can select a median element. Okay, you can select a pivot element as your last element, or any other given element here. It is not a compulsion rule that you have to select the last one only, you have to select the median only, or you have to select the first one only. Okay, the choice is yours, which pivot element you want. Now suppose we are going to discuss this whole algorithm with the help of this given example, which I have shown here onto your screens. Okay, this is my given array ARR. All right, that is my given array ARR. All right, these are the index values. So 0 to 8. So total n is equals to 9. Elements are 9 elements. Okay, so n is equals to 9 and index value 0 to 8. And these are the randomly inserted values, or say the inputs given by the user. And what is my aim? I have to bring my array like this. Okay. Now, suppose I select this 7 as my pivot element, the very first element. That's why it is yellow. Okay. This first element I am selecting as my pivot element. Now, what is the rule here? How can I come to know that my pivot element is at its appropriate place? You should note this down.
If it
Okay.
is less than if it is less than I plus 1.
I plus 1, yeah, correct. In general case, what Tushar has said is absolutely right. But
If it is not I plus 1, then we will switch it and then we will compare with another I plus 1 and we will make it we will do it in that way.
correct. See, when can you come to know that your key element or pivot element has reached or is placed at its correct position? When elements on the left side, of that pivot element are less than or equal to that key value. Suppose my key value here is 7. Okay, so with my swapping, with my iterations and all, with all the operations of quicksort, I got the position index value, correct position of this 7 as 5. Okay, see here at index value 5 my 7 is placed. Now how will I come to know that this 7 is placed at its right position, or say at its appropriate position, when all the elements on its left side, on the left subarray, are either smaller or equal to my key value, or say my pivot value, and the elements on the right side, on the right subarray of this pivot element are greater than. Okay, here I am not applying greater than or equal to, they should be greater than. Okay, on the left side I am applying less than equal to. So this you should note down. When can you say that your pivot element, or say the key element in your quicksort, has reached its appropriate position? When elements on left subarray are less than or equal to your pivot element, and elements on the right subarray are greater than your pivot element. Okay, so this is the partition, actually this is the division which I was talking about for the divide and conquer. Okay, and this partitioning you can say is the main thing, or say the main logic behind your quicksort. Okay, so how we are going to partition? You need some mechanism to partition it. So how we are going to start is, suppose here I'm going to write here 7, sorry, 7, which is my pivot element which I have selected. Okay, 6, 10, 5, 9, 2, 1, 15 and 7. All right, now you are going to take total 4 variables in your program. Okay, in your program you are going to take 4 variables, integer kind. All right, one variable is the lower bound. If you can see here, it is written LB. Okay, LB is the lower bound of your array, so that is one integer kind of a variable. One variable you are going to take is the upper bound, so integer UB. Okay, what is UB? The upper bound of your array, of your main array. Okay, so that is your UB. So when you are declaring your array and initializing, after that in your main function, what you are going to take? Two integers LB, integer UB. Okay, and what will be the value of those? Integer LB directly equal to 0. Why? Because your lower bound is always the index value 0. Okay, 1 2 3 4 5 6 7 and 8. Okay, your lower bound is always going to be 0, and because we are taking size dynamic in our program, so UB here you are not going to write directly 8, you are going to write upper bound equal to n minus 1. What is n? N is the size of your array. Okay, so size here, my size here, my n is what? 9. Okay, that's what my size is for the array. Okay, so my UB is what? N minus 1. So that is what you are going to take care in your program. When you are writing the program in your void main, after initializing and declaring your array, okay, and giving the values, you are going to take two integer variables LB and UB. Okay, lower bound and upper bound. And what will be their initial values? Lower bound is equal to 0 and upper bound is equals to n minus 1. I hope you guys are noting this down. Okay, now two variables taken, two more variables you'll take, integer kind. What are those? Start and end. Okay, you are going to take two more integer kind of variables called start and end. Why you are taking this start and end? Because they are going to be useful in your partitioning logic. Okay, we are going to partition with the help of this start and end variables. All right, now let's see the working mechanism first. This is this 7. Okay, this is done yellow because I am taking this 7 as my pivot element. So students, kindly understand now. Okay, we are not discussing the algorithm, we are discussing the working right now. Fine. Now suppose this 7 is my pivot element chosen by me. All right, now what I have to do, I have to find an appropriate place for this 7. Okay, now what I'm going to do is I'm going to start comparing the values, okay, of my this given array with this pivot element 7. If the value is less than or equal to my pivot element, if my value is less than or equal to my pivot element, then I will increment my start. Okay, I will move my start one step ahead. If the case is reverse, if the element, if the remaining element, okay, is greater than my pivot element, then I will move my end. Where I will move? I will move it onto the left side, okay, on this side. So that means I'm going to decrement my end. Okay, that is the two
Ma'am,
thing
it
which
will
I'm
be,
going to do. Yes, Tushar?
ma'am, it will be greater than or equal to or only greater than, because if
Only
same
greater than.
values like,
Only greater than. See, that's why it is written here. And that's why I told you guys to note down that what is my target, where should be my pivot element. My pivot element should be placed in such a manner that right subarray numbers are greater than my pivot element. See, that's why let me just highlight it for you so it will be easier for you to understand. Okay, numbers should be greater than my pivot element. And what about my left subarray? Number should be less than or equal to. Okay, so see, that's why if this is my resultant target array. So see, I have two entries for 7, but where is that second 7 placed? On the left side of my pivot element. Okay, this is my pivot element P. Fine. So I was explaining you the start and end. When are you going to move your start? When this pivot element, when compared with rest of these elements, okay, you find a condition that suppose 6. Let's take an example here, 6. Okay, 6 is less than 7. So what I need to do in that case, I need to move my start. Okay, so my start will move one step. So start plus plus. Okay, then I come to 10. Okay, next is what? 10. So 10 is not less than 7. What is 7? 7 my pivot element. 10 is not less than 7. So what I'll do, I'll go to this end part. I will compare the element which is pointed by my end. 7. Again, 7 greater than 7? No. 7 is not greater than 7. So again, I won't do anything here. Got it? That is what the mechanism is going to be happening. With me till here, everybody? Yes or no? With me till here?
so the pointer is not moving when the numbers are equal.
No, not on right side. Not on the end part.
Acha. Okay, okay.
Okay, let's start with the mechanism. Okay, 7, I selected my pivot element. Okay, now what is the condition? First check that wherever start is pointing at index value 0. So ARR of 0, what is the value? 7. And what is my condition? Number is less than or equal to my pivot. So my pivot is 7. 7 equal to 7. So condition is true. What I need to do in that case? Move my start. Okay, so start moves here. Again, again I will check. See, here how you are going to move this loop. When you will come to know that I have to again go for start or either for end. When start is less than end, so if you can see here, there is a one while loop here written. Before incrementing your start and decrementing your end, there is one while loop written. And what is the condition for that while loop? That index value, wherever start is pointing at, if that index value is less than the index value pointed by your end. See, that's why I'm repeating index value. I'm not saying the element value. Okay, I'm stating index value. So when index value start, okay, is less than my index value of end, then I have to look for these incrementing or decrementing of start and end. Okay, if the condition is false, then what you need to do, I'll explain it to you in a few minutes of time. But when you are going to go for this incrementing your start or decrementing your end, when start is less than your end, okay, so by start less than end I mean the index values. All right, so that you need to keep in mind. Okay, now again compare. Start is ARR of start. So that is ARR of 1. What is the value? 6. 6 less than 7? True. So what I need to do? Move my start one step ahead. Okay, so my start is here. Alright. Again, ARR of, start is less than end. Yes, 2 is less than 8. So I can proceed. So ARR of start, that is ARR of 2. What is the value? 10. Okay, 10 less than or equal to 7? No. So you are not going to increment your start. Okay, the start remains as it is at index value 2. You are going to go for the next line. What is the next step? You are going to check with the end. Okay, end ARR of 8. Okay, so 7. 7 greater than 7? No. So again you are not going to move this end. It is going to remain here as it is. Okay, so now what you are going to do? Now what you are going to do, if this is the case that you are not moving your start also because the element is not less than or equal to your pivot, and even end is also not greater than your pivot, then what you are going to do? You are going to swap the elements at the index value of start and end. Okay, with a given condition that start is less than end, only then you are going to swap, otherwise not. So see, index value start 2 is less than 8. Okay, 2 less than 8, so that is true. So what I need to do, I need to swap. So after swapping, what will be the array look like? 7, 6. Now instead of 10 you are swapping, so here again 7 will be here. Okay, 5, 9, 2, 1 and 15 remains as it is. Here it is 10. Okay, this is your start. All right, and this is your end. Fine, that is what you are
Ma'am,
going
can
to
you
do.
repeat it once again?
Yeah, see this here, when you went and compared with your pivot element, the condition is number should be less than or equal to your pivot, but number is not less than or equal to my pivot. So I'm not going to increment my start. My start will be staying at the position as it is. Okay, now I'm going to go and check with end. Okay, at end is pointing at index value 8 and value at that index is 7. Now what is the condition which I'm checking is the number should be greater than my pivot, but here the number is not greater than my pivot because 7 greater than 7 is not true. Okay, so even your end is not going to decrement. So in this case, what is your next step? You are going to
Swapping.
check. Yes, but before swapping, you are going to check that the index value of start is less than end. Then only you are going to swap. Okay, then only you are going to swap. So here my index value of start is 2. Index value of my end is 8. 2 is less than 8. So I can swap. Okay, so after swapping, what is your array looking like? Something like this. Okay, that here at pointer start is pointing to the value 7 now, and this pointer end is pointing to the value 10 now. Okay, this is after swapping. Got it? With me everyone? Yes or no? Till here, I hope everything is clear to everyone. Okay, but see, still our pivot element has not reached its, original place. Okay, now what we are going to do again, you are going to start this whole process, this whole line. Okay, this whole process you are going to start again. Why? Because your start index value start is at 2. Let me write here for you. Okay, all right. Now my start is at 2 index value. My end is at index value 8. Again you will start the same procedure. Again compare with pivot. Now the condition is what? Number, that is 7, less than or equal to pivot. Yes. So what I need to do? Increment my start. Okay. Again see, number, that is 5. 5 less than or equal to 7. Yes. So what I need to do? Increment my start. Okay. Start incremented. Again check. Number, that is 9. 9 less than or equal to 7? No. 9 is greater than. So my start won't increment. It will be remaining at index value 4. Now go and check with the end from this side. Okay. From here. End. End value is what? 10. 10 greater than 7? Yes. The condition is true. So what you are going to do? Decrement your end. Okay. Now end is at index value 7. Okay. Value at end is 15. 15 is greater than 7. Correct. So what I need to do? Decrement my end. So decremented my end. Now check again. Value at index 6. So that is 1. 1 greater than 7? No. It is false. So now next what I need to do? I have to check that index value of start is less than index value of end. So 4 less than 6. Yes. So what I need to do? Swap. What do I need to swap? Values of start with the value of end. Okay. So what I am going to do is, okay, I'm going to go for the swapping. So after swapping again, after you swap it, your values would look like here there is 1, okay, and here there is 9. All right. This is again after swapping. Again you swapped. Okay. Still you have not reached the correct position of this pivot. Okay. Now again you will repeat the same process. Again you are going to repeat this same procedure. Okay. Again check. Index value of start is less than end. Index value of start, that is 4. Less than end, that is 6. Yes. So go and start with the checking procedure. 1. 1 less than or equal to my pivot, that is 7. 1 less than or equal to my 7. Yes. So what I need to do? Increment my start. Okay. Now value is 2. 2 less than or equal to my 7. Yes. So what I need to do? Increment my start. Okay. So my start and end are going to be here at the same index value. Okay. Now 9. 9 is less than or equal to 7? No. So start will remain as it is. Start is not going to increment. Now come to this end. Check for end. End is where? At 6. Okay. So 9 again. 9 is greater than 7? Yes. So what I need to do? I need to decrement my end. So now my end is here. Okay. Now again check. 2. 2 is greater than 7? No. So my end is going to remain here. Now see here what is the case? Here the case is end is now less than my start. End is at index value 5. My start is at index value 6. Okay. So now I cannot run this while loop. Okay. This while loop which I was running, and I was doing the swapping, that swapping is not possible. Because why? The condition for that swapping was if index value of start is less than index value of end, then only I'm going to swap my start and end elements. So I told you that if this is not the condition, then what we are going to do? So that is what I'm going to tell you now. That if this condition occurs, that the index value of start is greater than the index value of end, in that case, you are going to swap the values of your end and your pivot. Okay, that means you found out the appropriate place for your pivot element. So see, if you go and swap this, I'll copy this whole thing again. Okay, you are going to swap 2 and 7. Okay, so now 2 will be here and 7 will be here. All right, so now what you are going to do, you got the appropriate place for this pivot element 7. Okay, now I'm going to remove this end and start here. Your partition for one selected pivot element ends here. Okay, and what you are returning? End. So end was pointing at this position. Okay, index value 5. So now this is fixed. For this 7, this index value is fixed. Okay, and if you want to check, see, I'll copy this for you. This is the resultant array which we have to reach. Okay, and if I copy it here, you can compare. See, this 7 has reached its index value, correct place. Okay, now what I have to do? Now I have to partition this portion into left subarray, and I have to partition this portion into right subarray. Okay, and if you observe, the elements on the left side of my selected pivot, okay, are less or equal to my pivot. Okay, and elements on the right side are greater than or equal to my greater than my pivot. Okay, with here, with me, everyone. Yes or no, students? See, this whole procedure, okay, till here, this whole procedure is done for only one element. Okay, that whole procedure is done for only one element. We fixed, or say we found out the appropriate place for one element. The same procedure recursively we are going to do for all the elements. But how we are going to partition? See, you are going to call one quick sort function, user defined function. Okay, there you are going to find the location. Here you found this location. Okay, because see, at the end of your partition you are returning the end, so index value 5 is going to get returned. So how we are going to call the recursive function now for this quick sort? Now your sub array will start from lower bound to location -1, that is 4. Okay, so this is your left sub array. This is your left sub array from lower bound to location -1. Okay, because see, your lower bound is not changing, neither your upper bound is changing. Okay, we are not changing the size of arrays, so that's why your lower bound and your upper bounds are not changing. So if you see, your left sub array is from lower bound to location -1. Okay, and what can you say about your right sub array? Your right sub array starts from location +1 to your upper bound. Okay, so that is how you have divided the given array into two parts. Got it? This one is your right array. Okay, and this one is your left sub array. Again, you are going to apply the same procedure. Select your pivot element. Okay, select your pivot element and apply the same procedures of comparing the start variable with the lower bound, or say the your pivot element. okay, and do the appropriate swapping. Okay, understood the working mechanism? Anybody having any questions here?
Ma'am, can you repeat the last step again?
Okay, see this green, I have marked this 7 as green because at the end of one procedure, or say this pivot element, I have
No,
found.
no, no, ma'am. Not this one. When we come out of from the while loop, जब while loop से बाहर आ
ओ,
जाता है, तब starter and
ओ,
reverse हो जाता है, अलग अलग पोजीशन पे आ जाता
अच्छा ठीक है, जब स्टार्ट और एंड, कंडीशन क्या है कि स्टार्ट ने सरपास कर लिया एंड को, स्टार्ट हैज सरपास्ड एंड, सो सी इंडेक्स वैल्यू ऑफ स्टार्ट इज 6 एंड इंडेक्स वैल्यू ऑफ एंड इज 5। तो अभी कंडीशन वाइल तो हमारी चलेगी नहीं, क्योंकि हमारी वाइल लूप की कंडीशन हमने क्या रखी है कि जब स्टार्ट इज लेस देन माई एंड, तभी ये कंपैरिजन होने चाहिए कि स्टार्ट को इंक्रीमेंट कर दिया या तो एंड को इंक्रीमेंट कर दिया, ठीक है। लेकिन अगर ये चीज नहीं हो रही है, स्टार्ट ने समहाउ सरपास कर दिया एंड को, सो माई स्टार्ट इज ग्रेटर देन एंड, इन दैट कंडीशन आई एम गोइंग टू डू द स्वैपिंग। बट स्वैपिंग अब किसकी होगी? स्टार्टिंग एलिमेंट और एंड एलिमेंट की नहीं, पाइवोट एलिमेंट और एंड एलिमेंट की, ठीक है। तो मैंने पाइवोट एलिमेंट जो मेरा 7 था, जो मैंने चूज किया था, उसको मैंने 2 की जगह पे रख दिया और 2 को 7 की जगह पे रख दिया। तो
है।
रिजल्टेंट एरे कुछ ऐसे
फिर
दिखेगा।
रिकर्सिवली वापस उसको फंक्शन को कॉल करते रहेगा,
करेक्ट,
सॉर्ट हो जाएगा एरे।
क्योंकि मैं क्योंकि
हाँ,
मैं एट द एंड ऑफ माय पार्टीशन फंक्शन क्या रिटर्न करवा रही हूँ? मेरा एंड का इंडेक्स वैल्यू, ठीक है। जहां कहीं भी मेरा एंड है उसकी इंडेक्स वैल्यू में रिटर्न करवा रही हूँ। कहां पे रिटर्न कर रही हूँ? क्विक सॉर्ट में वापस से। और उस क्विक सॉर्ट में मैंने वापस से रिकर्सिव क्विक सॉर्ट की फंक्शनिंग लगाई हुई है। और वो मैंने क्यों किया है? क्योंकि मुझे वो सेम प्रोसीजर जो मैंने ये 7 के लिए अब तक किया, ये पूरा यहां से लेके यहां तक का जो मैंने सेम प्रोसीजर जो मैंने इस पाइवोट एलिमेंट के लिए किया, वो मुझे सेम प्रोसीजर मेरे लेफ्ट सब एरे के पाइवोट एलिमेंट्स और राइट सब एरे के पाइवोट एलिमेंट्स के लिए करना है, ठीक है। यहां तक अब समझ में आ गया सबको? एवरीवन क्लियर टिल हियर, आई होप? ओके, so now how we are going to write this whole procedure, this whole mechanism. सबसे पहले what you guys are going to do in your program, you are going to write your main function, okay. You are going to declare the required libraries, okay, and you are going to uh, take, see, mark my words, take the size of array dynamic, static मत लेना, ठीक है। I want you guys to take the size of an array dynamically, okay. So main function, initialize and create your array. It is the easy part, and I hope everyone is very much now comfortable with initializing and creating your array, ठीक है। एक बार ये हो जाए, once you are done, give the values, random elements, okay, as inputs. That means you are preparing an array like this, okay, randomly inputs दे दो। Then what you are going to do, give the values, for your upper bound and lower bound। अभी start और end की values मत देना, let me just write it here। start और end की values मत देना, सिर्फ lower bound और upper bound की values, ठीक है। तो आपकी लोअर बाउंड की वैल्यू क्या हो जाएगी? योर एल बी इज इक्वल टू 0, क्योंकि वो इंडेक्स वैल्यू फिक्स्ड है हमारी, ठीक है। बट योर अपर बाउंड, दैट इज योर यू बी, यू आर नॉट गोइंग टू गिव द स्टैटिक साइज लाइक 9 या तो 10, ऐसा नहीं। You are going to give value as n minus 1. Why n minus 1? Because you are going to take the size of array in variable n, and your upper bound is going to be the value n minus 1. Okay, तो आपको values ऐसे
जीरो
देनी है
इंडेक्स
सबको। Fine, because I am asking you to take the size of array in a dynamic manner. So lower bound is 0, upper bound is n minus 1. उस main function से you are going to call your user defined function called quick sort. ठीक है, quick sort को call किया. What are the passing parameters in that? What are the arguments? Your array which you have made up, or say the given inputs by the user, that whole array you are going to pass. You are going to pass your lower bound and upper bound into it. ओके, तो कंट्रोल कहां जाएगा? कंट्रोल जाएगा आपके क्विक सॉर्ट में, यहाँ पे. ठीक है, अभी कंट्रोल इस साइड यहाँ पे क्विक सॉर्ट में गया. आपने क्या दिया हुआ है पैरामीटर्स? व्हाट आर योर फॉर्मल पैरामीटर्स? योर एरे, योर लोअर बाउंड एंड योर अपर बाउंड. ऑलराइट, now in that quick sort again you are going to check that if your lower bound is less than your upper bound. ऑलराइट, आपका लोअर बाउंड अपर बाउंड से लेस है तभी ये लूप चलेगी, वरना नहीं चलेगी. और क्यों नहीं चलेगी? क्योंकि एक पॉइंट ऐसा आएगा जब आपका कोई लोअर बाउंड या अपर बाउंड होगा ही नहीं. ठीक है, देन, और वो कंडीशन कब आएगी? व्हेन यू हैव रीच्ड दिस रिजल्टेंट एरे. ओके, तब ये फंक्शन नहीं चलेगा, अदरवाइज ये फंक्शन चलता रहेगा. ठीक है, एक बार आपको ये रिजल्ट मिल गया तो ये फंक्शन नहीं चलेगा. ठीक है, तो इफ योर लोअर बाउंड इज लेस देन अपर बाउंड, तो आपको क्या करना है? एक इंटीजर लोकेशन लेना है. ठीक है, ये लोकेशन क्यों ले रहे हैं? क्योंकि इस लोकेशन से हम अपना लेफ्ट सब एरे और राइट सब एरे डिसाइड करेंगे. तो ये वो लोकेशन हो गई. ठीक है, अभी देखो इंटीजर लोकेशन में आप क्या कॉल करवा रहे हो? व्हाट आर यू कॉलिंग एट द इंटीजर लोकेशन? द पार्टीशन फंक्शन. ओके, so that is again one more user defined function. One user defined function is your quick sort, another user defined function is your partition. This partition is actually the main mechanism of your quick sort. What are you passing as the arguments of this function? Again your array, the lower bound which is coming from this quick sort parameter, and the upper bound again which is coming from this quick sort parameter. Okay, so that is 0 and n minus 1 initially. Now the control is going to go to your partition function. तो ये हो गया आपका partition function यहाँ पे. Okay, you are passing arguments as array, lower bound, upper bound. Okay, now here inside that user defined function you are taking a variable called pivot. Okay, you are taking a variable called pivot, and what is the value? ARR of LB. See students, don't write ARR of 0 here, because every time your lower bound will change with respect to this right sub array. ठीक है, राइट सब एरे में आपकी लोअर बाउंड की वैल्यू क्या हो रही है? लोकेशन प्लस 1. सो यू कैन नॉट राइट ARR of 0. अगर लिख दिया, अगर वहां पे आप ऐसे लिख रहे हो pivot is equals to ARR of 0, then your function is not going to work correctly. Okay, so you have to write ARR of LB. Whatever value this LB is provided, that index value will be my pivot. ठीक है, that's why you are not going to write ARR of 0. So that your pivot element is what? ARR of LB. Wherever LB is pointing at whichever index value, that is my pivot element. Okay, what about start and end? Start is equals to the index value of your LB. Okay, end is the index value of your upper bound. Fine, my variables declared. ठीक है, अब mechanism चालू करो. So while start is less than end. Okay, यहाँ पे मैंने index value इसलिए लिखा है because students were getting confused with the element value and the index value. That's why what we are comparing here, we are comparing the index values wherever the start and end is present. Okay, so start is less than end, while what you are going to do again inside it, start, while ARR of start is less than or equal to your pivot. ARR of start, that means the value is less than or equal to pivot. I have to keep on incrementing my start. Okay, so मैं उतनी बार अपना start increment करती रहूंगी. अगर ये while loop गलत होती है, ठीक है, तो मेरा कंट्रोल जाएगा इस वाली वाइल लूप पे। वो क्या चेक कर रहा है, that if my end is greater than my pivot, then I have to continuously go on decreasing my end। ठीक है, जितनी बार मुझे ये चीज सही मिल रही है, this condition is true, ARR of end is greater than my pivot, then I have to decrement my end। okay, both these while loop are not true now। ठीक है, मतलब मेरा स्टार्ट भी अभी ग्रेटर लेस देन और इक्वल टू पाइवट नहीं है, मेरा एंड भी ग्रेटर देन पाइवट नहीं है। तो इन दैट केस व्हाट आई हैव टू डू, आई हैव टू डू द स्वैपिंग। लेकिन स्वैप करने से पहले मुझे एक चीज का ध्यान रखना है, दैट माई स्टार्ट इंडेक्स वैल्यू पॉइंटेड बाय स्टार्ट इज लेस देन इंडेक्स वैल्यू एंड। मतलब हमारा ये वाला केस देखो, यहाँ पे start is not less than or equal to 7, end is not greater than 7, okay, but the index value of start is 4, index value of end is 6, so 4 is less than 6, so I can do the swapping of the element at start and element at end। तो जब मैंने स्वैप किया तो 9 की जगह पे 1 आ गया था और 1 की जगह पे 9 चला गया। ठीक है, till here clear everybody? okay, but एक कंडीशन ऐसी भी आई, देयर वाज वन कंडीशन व्हेन माय स्टार्ट वाज नो मोर लेस देन एंड, दैट मींस माय एंड सरपास्ड, आई मीन द स्टार्ट सरपास्ड माय एंड, ये वाली कंडीशन। तो आप क्या करोगे, तो ये वाइल के लूप से बाहर आ जाओगे, डायरेक्ट यू विल स्वैप। what you will swap your pivot element and the end element, that is ARR of end। okay, so it is this condition, here my start has surpassed my end element। okay, so in that case मैंने क्या किया, I swapped 2 and my pivot element 7, so 7 की जगह पे यहाँ पे 2 आ गया और 7 की मुझे appropriate place मिल गई। for my pivot element 7 I found the appropriate index value और उस index value को मैं return करवा रही हूँ, so return end, so what I returned 5। अभी ये पार्टीशन कहां से कॉल हुआ था, क्विक सॉर्ट में से, यहां से। ठीक है, तो लोकेशन, दिस इंटीजर लोकेशन गॉट वैल्यू एज 5। नाउ आई एम गोइंग टू रिकर्सिवली कॉल दिस क्विक सॉर्ट, किसके लिए, मेरे लेफ्ट सब एरे के लिए, मेरे राइट सब एरे के लिए। सो अगेन द कंट्रोल इज गोइंग टू गो टू दिस पार्ट नाउ, क्विक सॉर्ट एरे लोअर बाउंड एंड व्हाट इज द अपर बाउंड फॉर दिस लेफ्ट सब एरे, ये क्विक सॉर्ट है आपके लेफ्ट सब एरे के लिए। ओके, और ये वाला क्विक सॉर्ट है आपके राइट सब एरे के लिए। फाइन, ओके, सो लेफ्ट सब एरे के लिए एज आई हैव एक्सप्लेन्ड इट टू यू, ये आपका जो लेफ्ट सब एरे है तो वो कहां से शुरू होता है, 0 to 4। ओके, सो क्विक सॉर्ट लोअर बाउंड, ओके, एरे लोअर बाउंड एंड लोकेशन -1। ठीक है, तो अभी यहां से वो फिर से कॉल करेगा the same, this is the recursive function call, again it will check lower bound less than upper bound, 0 less than 4, correct, so go with this integer location mein again partition is called। now for this partition what is the value of lower bound, the value of lower bound is 0, okay, and the value of upper bound यहाँ पे कौन सी वैल्यू आ रही है, देखो लोकेशन -1, okay, so that is 4, so that's why I told you। ठीक है, अभी पार्टीशन यहाँ पे कॉल हुआ है। ठीक है, क्विक सॉर्ट में यहाँ पे पार्टीशन कॉल हुआ विद द लोअर बाउंड वैल्यू एज 0, अपर बाउंड वैल्यू एज 4 एंड दैट इज फॉर योर लेफ्ट सब एरे। तो लेफ्ट सब एरे के लिए अभी पाइवट एलिमेंट क्या हो गया, लोअर बाउंड, ARR ऑफ लोअर बाउंड। ठीक है, तो लेफ्ट सब एरे के लिए यहाँ पे ये फिर से हो गया, जो उसका फर्स्ट एलिमेंट है वो फिर से उसका पाइवट एलिमेंट हो गया। ठीक है, स्टार्टिंग इज 0, यहाँ पे ये 0 हो गया एंड के लिए क्या हो गया 4 हो गया. अगेन यू आर गोइंग टू चेक स्टार्ट इंडेक्स वैल्यू लेस देन एंड इंडेक्स वैल्यू 0 लेस देन 4. सो अगेन स्टार्ट विद दिस व्हाइल लूप क्योंकि वो कंडीशन ट्रू है. ठीक है. व्हाट इज योर पाइवट एलिमेंट नाउ 2. 2 लेस देन इक्वल टू 2. यस. सो व्हाट यू आर गोइंग टू डू विथ योर स्टार्ट. और ये आपका एंड हो गया. ठीक है. इसके लिए इंक्रीमेंट योर स्टार्ट. तो यहाँ पे आपने इंक्रीमेंट कर दिया. अगेन चेक 6 लेस देन और इक्वल टू 2. नो. सो गो एंड चेक विथ एंड. एंड greater than or equal sorry greater than 2. No. So in this case what you are going to do, check 1 is less than 4. yes. तो क्या करना है स्वैप करना है. तो 1 की जगह पे 6 आ गया और यहाँ पे 1 आ गया. ठीक है. फिर से शुरू करो. 1 less than or equal to 2. yes. So what you do, increment your start. 7 less than equal to 2. no. So keep your start as it is. Go on the end portion. 6 greater than 2. yes. क्या करना है डिक्रीमेंट करो. 5 greater than 2. yes. क्या करना है डिक्रीमेंट करो. तो अभी स्टार्ट और एंड दोनों एक ही जगह पे. ठीक है. 7 greater than 2. yes. क्या करना है डिक्रीमेंट करो. तो यहाँ पे तो ये एंड. ठीक है. फाइन. अभी कौन सी कंडीशन आई दैट स्टार्ट सरपास्ड माय एंड. इन दैट कंडीशन व्हाट आई हैव टू डू, आई हैव टू स्वैप माय एंड एंड माय पाइवट. मेरा पाइवट 2 है, मेरा एंड है 1 पे. ठीक है. तो आफ्टर दिस स्वैपिंग यहाँ पे आ गया 2 और यहाँ पे आ गया 1 और मुझे क्या मिला 2 की एग्जैक्ट कंडीशन. ठीक है. तो नाउ आई एम गोइंग टू कम बैक हियर टू दिस लोकेशन पोर्शन. अब इसके लिए लेफ्ट कौन सा हो गया ये वाला 0. ओके. बिकॉज इट इज लोकेशन -1. तो देखो लोअर बाउंड और लोकेशन -1 दोनों एक ही है. ठीक है. तो अगेन यू आर नॉट गोइंग टू डू दिस. ये क्विक सॉर्ट यहाँ पे खत्म हो जाएगा. तो 1 की तो मुझे वैल्यू मिल ही गई. दैट वाज आई वाज टॉकिंग अबाउट दिस लोअर बाउंड लेस देन अपर बाउंड. एक ऐसी टर्म आएगी जब ये कंडीशन फॉल्स हो गई. तो इन दैट केस व्हाट यू कैन से यू गॉट द एग्जैक्ट वैल्यू ऑफ 1. समझ आया ये यहाँ तक सबको. This same procedure is going to run on your right sub array. ठीक है. ये मैं वापस से like I'm not repeating this again, but this same thing is going to happen on your right sub array. And that's why see in your right sub array the lower bound is location +1 and your upper bound. Okay. Now everyone, you don't have to do anything now much. Okay. जो भी आपको करना था whatever is the main thing is already written here for you guys. Okay. This is the exact code which you are going to write. You just have to work on your main function. ठीक है. And in that main function also what you have to do, what is your part to code is you have to create and initialize your array. Okay. Because you are taking it in dynamic size, so you have to run one for loop to scan the elements and give the lower bound and upper bound value and call this quick sort. बस इतना ही आपको करना है. बाकी का सब कुछ the whole code basically 80% of the code is written here. You have to write this same code. Okay. Everyone got it? Any doubt in the instructions? Start coding. Start your code. But see, there is one condition here. I do want to cover this bubble sort also in this particular lab because with B and C batch, I have covered bubble sort. Okay. So I don't want A batch, my A batch students to lag behind. But in that case, you have to support me and code a little bit in a faster manner. Okay. A little bit quick. And that's why I have written this whole logic here for you. You just have to copy it in your code. Your part is to just integrate. Okay. मैंने यहाँ पे सिर्फ एरे की डिक्लेरेशन और इनिशियलाइजेशन और वो फॉर लूप नहीं लिखी है, बाकी ऑलमोस्ट पूरा कोड यहाँ पे है. So you guys be little bit quick. Keep tab on timing. It is 1 o'clock right now. By 1:15 or latest by 1:20, you should be completing your program. Because you don't have to think here. Actually, you understood the mechanism, you understood the logic. And here in front of your screen is the actual two main user defined functions. So you just have to write your main function. These two user defined functions are already there. So you just have to copy them, and one swap function which you have to write. Okay. And swap function is, I guess, pretty much easy for everyone now. Okay. So you have time till 1:20 to code. In between anyone finishes, you are free and I will be glad to see your program. Okay. Even if you have any doubts, any errors, then also do ping or just ask me. I'm here only. All right. So everyone start coding. This is your practical number 12 and also the theory topic of your unit number 4. Students, any doubts anywhere? And guys, please keep a tab on your timings, okay? Exactly at 1:20, I will ask any random student to present their screen. Anyone completed? Yes, students. Anyone finished? Vidhi, Manav, Nikita, Jaydeep.
मैम एरर आ रही है।
क्या एरर है?
पता नहीं फंक्शन में कुछ एरर आ रही है क्विक शॉट पे।
Show me your screen.
यस मैम।
Hmm. Okay. With the integer lower bound equal to 0 और upper bound दोनों को अलग कर दो. कोड ब्लॉक्स यूज कर रहे हो ना?
यस मैम।
दोनों को अलग अलग इंटीजर्स में ले लो पहले. ठीक है. Go down. Okay. Try to run your program now.
इट्स स्टिल शोइंग मी एरर।
एरर लॉग दिखा सकते हो मुझे इसकी?
मैम कहाँ दिखेगी वो?
Go to your view in menu bar view. There it is logs. Okay, start is undeclared.
नो आई डिक्लेयर्ड इट।
What is the expression? Location is undeclared. Before token. Line number 44. Vidhi, keep these three statements inside the curly braces. if loop के जो ये तीन है, तीन
ओके
अपने स्टेटमेंट्स लिखे उसको कर्ली ब्रेसेस के अंदर लिखो. Line 14. पार्टीशन में भी पाइवोट एलिमेंट के बाद वो आपने सेमीकोलन भूल गए हो. अभी वापस से बिल्ड करो. लाइन नंबर 14 पे ऊपर जाओ. Go to your quick sort. Do one thing. Define this quick sort globally.
Which element?
Define the quick sort globally.
Okay.
विधि ऐसे नहीं. I meant क्विक सॉर्ट का पूरा लॉजिक लिखने से पहले क्विक सॉर्ट आप यूज करने वाले हो वो डिफाइन कर दो. सो हैश इंक्लूड के बाद void क्विक सॉर्ट इन द ब्रैकेट इंटीजर एरे इंटीजर बस ऐसे.
ओके मैम, आपने बोला कि क्विक सॉर्ट फंक्शन को.
ऐसे नहीं void लिखो. void क्विक सॉर्ट ब्रैकेट में इनसाइड पैरामीटर की टाइप लिख दो. तीनों की तीनों पैरामीटर की टाइप. इंटीजर.
ओके, सिर्फ उतना ही लिखना है.
वो सब कुछ सही था. जहाँ पे आपने प्लेस किया हुआ था वो सब कुछ सही था.
हाँ.
सेमीकोलन भूल गए. अभी भी कॉन्फ्लिक्टिंग क्विक सॉर्ट क्यों है? सॉल्यूशन को क्लीन करके फिर से रिबिल्ड करो. तब तक मैं दूसरे का देख के आती हूँ.
ओके.
स्टॉप प्रेजेंटिंग. सॉल्यूशन को क्लीन करो एंड रिबिल्ड अगेन. तुषार
यस मैम.
प्रेजेंट करो स्क्रीन.
मैम अभी हम कुछ काम से इम्पोर्टेंट कुछ इशू आ गया तो हम बाहर गया तो हम अभी आया. अभी हम करना शुरू करें. इशू आ गया.
ओके. रिद्धि प्रेजेंट स्क्रीन. विजिबल. जाओ अपने कोडिंग पे. रिद्धि गो टू योर कोडिंग. I am just able to see the meeting window or say the Chrome tab. मुझे और कोई आपकी स्क्रीन नहीं दिख रही है कोडिंग की.
Just a second, ma'am. I will share it again.
Okay. Visible. रिद्धि कोड थोड़ा गलत है लॉजिकली. कोडिंग सही की है लेकिन स्टेप्स ऊपर नीचे कर दिए. मेन फंक्शन में जाओ. See students, general instruction to everyone. I know your partition and your quick sort will be right. क्योंकि वो तो मैं ही दे रही हूँ आपको कोड में. ठीक है. And it is working. Even I have tried it myself and it is working. Those set of code is working. ठीक है. So I just want to see how you guys have integrated. क्योंकि आपका काम क्या था? एरे को कॉल करना. ठीक है. एरे बना के उसको क्विक सॉर्ट में कॉल करवाना. बाकी का क्विक सॉर्ट का लॉजिक, पार्टीशन का लॉजिक वो तो मैं ही दे रही हूँ. So that is going to be right. Okay, just I want to see if you guys are able to integrate it with your main function or not. Right? Okay. रिद्धि, आपका लोअर बाउंड और अपर बाउंड वो आपने एलिमेंट्स को स्कैन करवा दिया ना, उसके बाद आएगा, पहले नहीं आएगा. क्योंकि n की साइज आप बाद में ले रहे हो. देखो उससे पहले ही आपने अपर बाउंड में उसको n-1 दे दिया, तो वहां पे तो वो गार्बेज वैल्यू चली गई. क्योंकि n की तो साइज आपको मिली ही नहीं है ना. उससे पहले आपने n-1 वहां पे लिख दिया है. सो दैट प्लेस ऑफ कोडिंग इज रॉन्ग. अपर बाउंड और लोअर बाउंड को वहां से हटाओ और उसको आपकी फॉर लूप के बाद में आपको डालना है. एंटर द एलिमेंट्स. वहां उसके बाद आपको एक फॉर लूप लगानी है. उस फॉर लूप में आप सारे एलिमेंट स्कैन करवाओगे. वो फॉर लूप कितनी बार चलेगी? जितनी बार आपको n मिला है. ठीक है. कमेंट में वहां पे लिख दो फॉर लूप. कमेंट लिखो वहां पे. कोड फॉर लूप टू स्कैन. फॉर लूप टू स्कैन. ठीक है. फिर इंटीजर LB UB. ठीक है. अभी वहां पे कमेंट करो फिर से. कॉल क्विक सॉर्ट फंक्शन. क्विक सॉर्ट है रिद्धि, शॉर्ट नहीं. SORT. यहाँ पे आपको अपना क्विक सॉर्ट कॉल करवाना है. ठीक है. वहां पे आप अपने एरे पास करोगे पूरा, और आपका लोअर बाउंड और अपर बाउंड. आपने एरे भी डिक्लेयर नहीं किया है तो डिक्लेयर करो एरे. ठीक है. बाकी तो पूरा सही ही होगा. स्वैप फंक्शन भी सही है. ठीक है. इतना करो, बट बी क्विक. स्टॉप शेयरिंग. राज,
Yes, ma'am.
present your screen.
Yes, ma'am. Ma'am, present.
Yes, visible. मेन फंक्शन में जाओ सबसे पहले.
मैम मैंने यहाँ पे दो फंक्शन अलग अलग नहीं बनाए हैं। मैम पार्टीशन और क्विक शॉट एक ही में लिखा है, क्योंकि थोड़ा मैस लग रहा था मुझे, तो फिर मैंने एक ही में लिख दिया।
ओके, मैं देख लेती हूँ, 1 मिनट रुको तो फिर।
ओके मैम।
क्योंकि वो मैस ना लगे इसी वजह से मैंने दो हिस्सों में उसको बांटा था कि भाई एक आप क्विक सॉर्ट रिकर्सिवली, आई मीन यू आर कॉलिंग, and in that recursive you are, simplifying that. I am calling the partition function.
मैम मुझे ऐसे थोड़ा इजी लगा तो फिर मैंने ऐसे कर दिया।
Yeah, it's okay. कोई ऐसा कंपलसरी नहीं है कि जैसे मैंने बोला वैसे ही कर सकते हो, इट्स फाइन।
ओके।
ठीक है, ऊपर जाओ, गो टू योर फंक्शन। ठीक है, नीचे जाओ थोड़ा। Okay. Fine, I can see the output also. All right. Okay, you can stop presenting.
ओके।
Anyone else who has finished? Because I told you to keep tab on your timing and it's already 10 minutes past. I have given you the what time to do this programming. Anyone else? Manav, Yashang, Josh, where you guys have reached? Give me the status where you guys have reached. Okay, students who are present in the session will say yes. Bipin? Girish? Josh? Manav? Raj is there, I know. Riddhi is also there. Smriti? Vidhi is also there. Yashang? Okay. Josh, Manav, I want status from you guys. Where have you reached in the coding? See, I'm not asking you to share your screen. I'm just asking the status. The reason, Josh? What about laptop? Laptop and dot dot dot. See guys, if you are not doing, you are losing here. Okay. Because I don't want to rush here, but then also you cannot take this much of time when the code is itself given to you. I would have understood the situation when I would have told you that okay, this is the mechanism. मैंने ये explain कर दिया, अब आप लोग code करो. लेकिन ऐसा तो है नहीं. I have given you the full logic, or I can say the exact code which you have to write. You just have to integrate it with your array of your given size. बाकी सबको तो बाकी 80% of the code तो मैं ही दे रही हूँ. Still you guys are not able to do it or not doing it due to one or the other reason. Not done. Actually not done on your part. Okay. See, this instruction is for all of you. Okay. In general, you have to complete this program. Alright, because soon I'm going to ask to submit this program. Fine. And I hope it is working for everyone right now. Though there will be minor errors, but it's okay. But still, if you are not able to complete it, you are stuck in between, then this is for everyone. Contact me. Okay, you have my email address. Send your code there. Okay, because right now, either due to network issues or due to time constraints, I'm not able to see each and every one of your screen, or either you guys are not very much comfortable in sharing your screen. That is understood, fine. But then don't take this in a very lighter manner कि ठीक है ना, मैडम ने नहीं देखा तो कर देंगे, किसी का कॉपी कर देंगे. I know this temperament, but don't do it, otherwise it will be a habit. Reach out to me, you have my email address. I'll work out on your program. I'll point out what is the error, what mistake you are doing, and I'll revert you back. Okay? Hope the instruction is clear, crystal clear to everyone. Yes or no? Alright. We are going to the next sorting, that is a bubble sort. Again, everyone is requested to take notes. Okay? Because this is again the part of your theory. Not only just practical, but your theory too. The next sort that we are going to discuss right now is your bubble sort. Heard about bubble sort? Anyone? Anyone has
Yes.
any idea about
Yes.
bubble sort?
Yes.
What is
Swapping to adjacent element until it gets to its right position.
exactly? So what you are doing in bubble sort is you are comparing the adjacent elements. Okay? You are comparing the adjacent elements. That is what the working principle is. What is the working principle in your quick sort? The quick sort working principle was divide and conquer. Okay? Here, in this bubble sort, the working principle is comparing the adjacent elements. Now, in that comparison, let's say A of I. Okay? If A of I is greater than A of I plus 1, This is my logic, okay, for the comparison. If a of I is greater than a of I plus 1, then you are going for swap. Swap between a of I and a of I plus 1. Okay, but if it is not, then you will go for the next comparison to the next adjacent element. Okay, for example, I have an array. Okay, let's say the array elements are 15, 16, okay, 6, 8 and 5. Okay, suppose this is my given array. All right, index values are 0, 1, 2, 3, 4. All right, so n is equals to 5. Fine, this is my given array, given input of an array. Now what I have to do, my target is I want to arrange this array into ascending order, sorted in ascending order. So what I'll do, let's say I'm taking pass 1. What is my pass 1? This pass 1 is nothing but my procedure number 1. Okay, I'll start comparing with the first element, that is 15 and 16. Okay, I will compare. Let me just write here 6, 8 and 5. Now these two elements will be compared. Now this is my I, so obviously this becomes my I plus 1. Okay, so first comparison between 15 and 16. I greater than I plus 1? No, so I don't need any swap. Okay, if this condition was true, okay, if this was true, then I was going for swap between a of I and a of I plus 1. Okay, but here that condition is not true, so I'm not going to swap. So in that case, what I have to do, I have to compare the next adjacent elements. Okay, so 15 remains as it is here, 16, 6, 8 and 5. Alright, so next comparison is between 16 and 6. Do I need swapping? Yes. Why? Because a of I is greater than a of I plus 1. So once it is swapped, your resultant array looks like 6, 16, 8 and 5. Okay, so that is one swapping done. Now go for the next adjacent elements. What are the next adjacent elements? The element at index 3, index 2 and index 3. Okay, so now the element at index 2 is 16, element at index 3 is 8. So again you are going to compare these two. Okay, again a of I greater than a of I plus 1, condition true. So what I need to do, swap. So 6, 8, 16 and 5. Now next adjacent element are to be compared. So next adjacent element starts from index value 3. Okay, so 16 and 5 again gets the comparison. Do I need this comparison? Yes. Again 15, 6, 8, 5 and 16. Now see, by this we are going to end. Okay, here we are going to end. Now here you found that we have reached the correct position, or we have found the correct position of 16. Okay, so this comparison, this again everything is going to repeat itself, because for the 16 we have found out the correct position. So now we are going to, let's say we consider it as pass 2. For pass 2, the target array is 15, 6, 8, 5 and 16. Okay, again you will start the comparison from the first adjacent elements. So 15 and 6. Do I need swapping? Yes. So 6, 15, 8, 5, 16. Now adjacent elements, move further. Okay, so next adjacent elements are what? 15 and 8. Do I need swapping? Yes. So after swapping 6, 8, 15, 5 and 16. Okay, next adjacent elements. Now for this particular iteration, 15 and 5, do I need swapping? Yes. So after swapping, your array will be 8, 5 15 and 16. Next element adjacent are 15 and 16. Do I need this swapping? No. So what can I do? I found the right place for my 15. Okay, and this marks the end of my pass 2. Now I have to sort this 3. So I'll go for pass 3. In my pass 3, my target array is 6, 8, 5, 15 and 16. Okay, so again start. 6 and 8, do I need swapping? No. Okay, so these two elements won't get swapped. Now, next adjacent elements 8 and 5. Do I need swapping? Yes, because 8 is greater than 5. Okay, so 6, 5, 8, 15 and 16. Next adjacent elements 8 and 15. Do I need swapping? No. Okay, so again 6, 5, 8, 15 and 16. Now next adjacent elements 15 and 16. Do I need swapping? No. And as there is nothing adjacent to 16, of course, so you found out that this is the right position for 8. Okay, now this is the end of pass 3. Now we'll go for pass 4. Okay, in pass 4, what is the target array? 6, 5, 8, 15 and 16. Okay, adjacent elements to be compared are 6 and 5. Do I need swapping? Yes. So 5, 6, 8, 15 and 16. Okay, next adjacent elements to be compared 6 and 8. Do I need swapping? No. So again 5, 6, 8, 15 and 16. Next adjacent elements 8 and 15. Do I need swapping? Again no. So again 5, 6, 8, 15 and 16. Next adjacent elements 15 and 16. Do I need swapping? No. So as there is nothing adjacent, so I found out that I got my resultant array 5, 6, 8, 15 and 16. Everybody got till here the working mechanism?
Yes.
Anybody has any doubts here in this mechanism? Any questions you guys are coming up with? Any doubts or any questions you guys are coming up with? Anyone? Okay. So if I want to write the logic for this, okay, if I go and write the logic or say the code for this, then there are some observations. What are the observations? The observation is that the number of passes which I need, okay, how many passes did I make? 4. Okay, the number of passes is equal to n minus 1. There were n, what is n? 5. There are 5 elements to be sorted. How many passes did I require to sort all the 5 elements? 4. Okay, so that is a general observation that number of pass is equal to number of elements minus 1. Okay, that is a general case. I'm not saying it is always going to be the same, but this is the general case. Okay, so what you can make out of this, that if you sort 4 elements, if you sort 4 elements, that means the 5th element will come automatically at its right place. If we make a general statement here, then that statement will be that out of the 5 elements, if you sort any 4 elements, okay, then the 5th element will come automatically to its right position. That is what the general statement you can make out. Now, as we are maintaining this pass, okay, so in our code also, we are going to maintain a loop, one loop for this pass and one loop for comparisons. Okay, so ideally there will be two loops. So if I go and write those loops, okay, so I'm going to write one for loop for. This for loop is for your passes, okay, to maintain the pass. I is equals to 0. That is pass number 1. So I is equals to 0. I is less than n minus 1. See, because of our general case, number of pass is equals to number of elements minus 1. Okay, so I is less than n minus 1. Okay, I plus plus. So incrementing my passes. Okay, what I need to do in that, I need to look out for the comparisons. So again, one for loop. Let's say j is the variable which is pointing, okay, to the array indexes. So j is equal to 0 because I want to start my adjacent elements to be compared from the 0th index. So j is equals to 0. J less than n minus 1. Okay, because it should go till index 4. My n is 5, so it should go till index 4. Okay, so j less than n minus 1. J plus plus. Okay, so this loop is for your comparisons. Now what do I have to compare inside that for? Again I have to write if my ARR of j, okay, that means the comparison between the two numbers pointed by j, ARR of j is greater than ARR of j plus 1. That is my condition for the comparisons. If this is true, if this condition is true, then what I have to do? I have to swap. Whom should I swap? I should swap my ARR of j with ARR of j plus 1. Okay, this is my end of if, this is my end of for, and this is my end of main for. Okay, again for your information, this one is loop for passes. Okay, this is the loop for your passes. All right, this one is the loop for comparisons. Okay, and inside that loop you are applying your condition and then you are swapping. That's all. This is the logic for your bubble sort. Okay, but there was a reason that again and again I was asking you guys that you guys don't have any
Ma'am,
questions.
I have a
Don't have.
question. I have a question.
Yes, Tushar.
टाइम कॉम्प्लेक्सिटी इसका और o टू द पावर n स्क्वायर चला जाता है तो फिर ऑप्टिमल सॉल्यूशन तो नहीं है इसका.
Exactly. ये क्यों हो रहा है? देखो, when you are going and till this pass one, it's okay. ठीक है? But in this pass two, once you reach here at this place 15, so you know that 15 is at its correct place, 16 is already at its correct place, 16 की तो हमने जगह फिक्स कर ही दी है. ठीक है? फिर भी we are comparing, still we are comparing 15 and 16, though we know that it won't get swapped. The same thing here. यहां तक ये जो हमारी नेक्स्ट पास 3 में जो हमारा टारगेट था, तो 15 और 16 की तो जगह ऑलरेडी फिक्स थी, तो वापस से 8 को 15 के साथ कंपेयर करने की कोई जरूरत नहीं थी. राइट? हियर ओनली यू गॉट योर टारगेटेड sorting. Same thing on this side. Here also in pass 4, you already had fixed the value of 8, 15 and 16. Still you are comparing 6 and 8, 8 and 15, 15 and 16. So what you are doing basically, you are increasing the processing time, thus increasing the complexity. ठीक है, अभी देखने जाओ, if you observe that whenever the I value, what is this I value? It is the loop for your passes, okay, pointed by your variable I. So what you can make out, that whenever the value of I increases, the number of comparison decreases. ठीक है, यहाँ पे यहाँ पे देखो I is equals to 0 था, ठीक है, ये है आपका I is equals to 1, ऑलराइट, इंक्रीज हुई, यहाँ पे है आपका I is equals to 2. अभी देखो यहाँ पे जब I is equals to 1 था, ठीक है, तो आपको 3 कंपैरिजंस की ही जरूरत थी टू गेट द फाइनल आंसर. ठीक है, ये 15 और 16 को कंपैरिजन करने की जरूरत नहीं थी. यू गॉट योर आंसर व्हेन यू स्वैप्ड दिस 15 एंड 5. फिर पास नंबर 2, कितनी कंपैरिजंस की आइडियली जरूरत थी? सिर्फ 2. तो जैसे ही I की वैल्यू इंक्रीज हुई, कंपैरिजंस की वैल्यू डिक्रीज हुई. ठीक है, क्योंकि ये फिर 8 और 15 और वापस से 15 और 16 को कंपेयर करने की जरूरत नहीं थी आपको. ऑलराइट, सो what you can deduce is that whenever the I value increases, this comparison value decreases. तो आपको जो लूप में मॉडिफाई करना है, दैट दिस लॉजिक इज नॉट एब्सोल्युटली राइट ओइंग टू द टाइम कॉम्प्लेक्सिटी. ओके, सो वी विल ऑप्टिमाइज दिस. ये कोड तो सही है, आपको आपका सॉर्टेड बबल सॉर्ट में मिल भी जाएगा आंसर, but it will take more time. Okay, and to modify, to optimize that, we will do some change in the loop for comparison. क्यों कंपैरिजन में? क्योंकि we deduced that when the passes, number of passes or this I value increases, मेरी कंपैरिजन कम करनी है मुझे. ठीक है, तो आप लोग अपनी इस वाली फॉर लूप में, ये फॉर लूप में मॉडिफिकेशन करोगे. और इसमें क्या मॉडिफाई करोगे? फॉर j इज इक्वल्स टू 0, j लेस देन n माइनस 1 माइनस I. ठीक है, n माइनस 1 माइनस I, j प्लस प्लस, ये करोगे तो क्या होगा इसमें? वो यहीं तक जाएगा. ठीक है, फॉर एग्जाम्पल इफ I इज इक्वल्स टू, यहाँ पे या तो I इक्वल टू 2 का ले लो यहाँ पे. ठीक है, I इज इक्वल्स टू 2, तो वो सिर्फ यहीं तक जाएगी लूप. इसके बाद उसको पता चल जाएगा कि मेरा रिजल्टेंट आ गया यहाँ पे, दिस इज माई रिजल्टेंट. इसके आगे मेरे को 8, 15 और 15, 16 को कंपेयर नहीं करवाना अभी. ठीक है, यही इसका रिजल्टेंट आ जाएगा, तो यहाँ पे दैट लूप विल स्टॉप ऑटोमेटिकली. अंडरस्टूड you guys why we are modifying, why we are optimizing? And this is the code which you are going to apply. Okay, either you can directly apply in your main function. ठीक है, again you have to do the same thing. main function लिखो अपना. ठीक है, declare your arrays. Fine, declare and define your arrays. array की size dynamic रखना. All right, so again you have to write your printf and scanf statements. printf, enter the array elements, for loop. ठीक है, for loop के अंदर आपका scanf का statement for the n value which you are giving. all right, और उसके बाद directly you can write this for this whole 4 lines of codes, or you can call your bubble sort function. okay, तो फिर आपको उसमें बबल सॉर्ट में आपको अपना एरे पास करवाना पड़ेगा. ऑलराइट, See, that's why I told you that bubble sort is much smaller in comparison to quick and merge. But you guys took a little bit time more than estimated in quick sort. But fine, it's okay. So you guys can take a screenshot of this. Kindly take a screenshot, everyone.
मैम
This is तुषार.
मैम
हाँ तुषार बोलो.
मैम कैन यू हियर मी?
यस यस क्लियरली बोलो क्या हुआ.
मैम फिर भी ये इतना ज्यादा ऑप्टिमाइज नहीं हुआ सॉल्यूशन। 2 लूप चल रहा है, 2 लूप चल रहा है तो टाइम तो लेगा ही। इसको और
टाइम
ऑप्टिमाइज कर
लेगा
सकते हैं।
लेकिन वो ये जो एक्स्ट्रा एक्स्ट्रा काम कर रहा है ना तुषार, पास 1 के बाद पास 2 में उसने एक एक्स्ट्रा काम किया, पास 2 में उसने 2 एक्स्ट्रा काम किए, पास 3 में उसने 3 एक्स्ट्रा काम किए, वो कम कर रहे हैं हम लोग.
तो मैम सिंपली एक काउंटर को कैरी करके, काउंटर जब हो रहा है तो काउंटर को इंक्रीज करने से सीधा आंसर आ जाएगा। काउंटर जब एक उसको सॉर्टेड मिल रहा है, वो काउंटर बढ़ा रहा है तो वो एरे का साइज छोटा करते जाएगा, तो उसमें दो 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 लूप भी नहीं लगेगा, तो स्पेस भी बचेगा, टाइम कॉम्प्लेक्सिटी भी घट जाएगा, ओ रेस टू एन हो जाएगा, ओ एन हो जाएगा।
That is an entire different approach. That is an entire different approach. मैं इस अप्रोच की बात कर रही थी यहाँ पे कि जहाँ पे हम लोग 2 फॉर लूप्स को लेके
तो मैम
बाद
दो
में
फॉर
हम
लूप
लोग
तो
अपना प्रोग्राम कर रहे हैं.
कॉम्प्लेक्सिटी ओ रेस टू एन स्क्वायर में भेज देता है ऑलरेडी, ओ रेस टू एन स्क्वायर में भेज देगा।
हाँ तो मैंने मना नहीं किया है कि आप लोग दूसरे मतलब तरीके से नहीं अप्लाई कर सकते. ऑफ कोर्स यू कैन डू इट.
तो मैम अगर कभी प्रॉब्लम में कंस्ट्रेंट आ जाएगा तो प्रॉब्लम हो जाएगा इसी, या अगर हम लूप लगा के करेगा तो। क्योंकि
कंस्ट्रेंट कैसे कंस्ट्रेंट्स लगा रहे हो?
जैसे अगर कोई कहीं पे भी हमको मतलब मिल गया कि कहीं पे हमको ये अगर बबल सॉर्ट अप्लाई करना है, वहां पे अगर कोई प्रॉब्लम के अंदर हमको बबल सॉर्ट एज अ फंक्शन अप्लाई करना है, उसके बाद मेरे को कंस्ट्रेंट दिया हुआ है कि हमको इसका रेंज के अंदर रहना है। अगर हम लूप लगाएगा और मेरा कोई और फंक्शन में हमको ज्यादा स्पेस चाहिए तो फिर कंस्ट्रेंट प्रॉब्लम भी तो आ जाएगा।
तो आप काउंटर
ये
मेंटेन
तो
कर रहे हो, तो
ऑप्टिमाइज नहीं हुआ ना।
काउंटर मेंटेन कर रहे हो तो काउंटर का भी तो वही प्रॉब्लम नहीं आएगा तुषार. सेम इश्यू होगा.
मैम बट ज्यादा ऑप्टिमाइज है ना, क्योंकि वो स्पेस ले लेगा, चलो स्पेस ज्यादा ले लेगा, 4 4 बाइट और ले लेगा, प्लस मगर वो टाइम कॉम्प्लेक्सिटी में तो कम हो जाएगा ना, क्योंकि उसको 2 लूप में घूमना नहीं पड़ेगा, दो
करेक्ट.
लूप के अंदर घूमना नहीं पड़ेगा, उसको एक लूप में काउंटर करके फिर वो लूप ऑलरेडी वो डिक्रीज हो जाएगा नीचे जाके, जब भी वो फंक्शन आएगा कॉल होगा।
एब्सोल्युटली राइट. लेकिन बार बार उसको काउंटर को एक्सेस करके फिर बार बार वो एक ही चीज अगर वो अगेन एंड अगेन इट इज डूइंग, तो इट इज बेटर टू डू दैट इन लूप. मना नहीं कर रही हूँ, सही कह रहे हो. अगर कॉम्प्लेक्सिटी और अगर स्पेस कॉम्प्लेक्सिटी और टाइम कॉम्प्लेक्सिटी को देखा जाए तो योर सॉल्यूशन इज मोर ऑप्टिमाइज्ड. ठीक है. बट इट इज योर वे. अगेन मैंने काफी बार भी अब हमारी लैब्स में मैंने ये बोला है कि व्हेन द प्रोग्रामर चेंजेस द अप्रोच आल्सो चेंजेस. ठीक है. और easiest way right now what we are talking is about
बट
the advanced level. We are
बट
talking
मैम
about the advanced level.
इजीएस्ट में
The
तो कोई भी
easiest way
ब्रूट
to
फोर्स लगाने से हो
understand.
जाएगा, 2 लूप 3 लूप लगा के करने से भी हो जाएगा। ऐसे तो आप 5 है तो 4 लूप लगा के भी कर सकता है, एक एक में एक एक बढ़ा के।
नहीं
वो
तो
तो
फिर लूप लेने की जरूरत ही नहीं है ना. अगर मैं हर एक पास के लिए मैं एक एक लूप लेती हूँ तो लूप का मतलब ही नहीं रहता है तुषार. लूप हम क्यों ले रहे हैं? क्योंकि हमको एक ही चीज बार बार करवानी है, इसलिए हम लूप लेते हैं
तो
ना.
मैम वही,
बेसिक्स है ये तो.
हाँ तो
ये तो बेसिक्स है
तो
लूप्स के.
बेसिक्स,
तो लूप क्यों
हाँ तो
लेते
फिर
हैं?
मैम वही तो बोल रहे हैं मैम, फिर पॉइंटर से तो इजी हो जाएगा ना। पॉइंटर भले ही एक 4 बाइट आपका ज्यादा लेगा, मगर फिर वो काम तो वही करेगा ना, कि पॉइंट कम करके आपको घूमना नहीं पड़ेगा, एक ही लूप में खत्म कर देगा काम।
तुषार तो मैं यही बोल रही हूँ कि ये आपका अप्रोच है. मना नहीं कर रही हूँ कि ये गलत है. ठीक है.
ठीक है।
लेकिन ये वाला जो अप्रोच है, बाय मेंटेनिंग द पास and by maintaining the comparisons inside the pass, एंड देन ऑप्टिमाइजिंग। ये सबसे बेसिक और सबसे इजीएस्ट है। पहले बेसिक से तो चालू करो, फिर जाके हम एडवांस पे जाते हैं ना। ऐसा तो नहीं है कि हम डायरेक्ट एडवांस पे ही जंप कर दे। if we are talking, though you guys don't have
नहीं
that
मैम, नहीं मैम, नहीं मैम,
time
मैम
complexity,
मेरा क्वेश्चन ये नहीं था।
तो
मेरा
फिर
क्वेश्चन ये
क्या
था कि
था
अगर
आपका
कुछ भी
क्वेश्चन?
कुछ भी करना है, अगर हमें एक लूप लगाया है, लूप में हम 4 पॉइंटर भी हम लगाते हैं तो मेरा स्पेस बचाता है, तो उसके बाद वो तो नहीं होता ना कि टाइम कम बच जाता है, स्पेस भले ही थोड़ा ज्यादा ले लो अगर कंस्टेंट का साइज बढ़ा दिया हुआ है तो अगर पॉइंटर्स लेके करेगा तो पॉइंटर्स इज वे बेटर ऑप्शन देन क्रिएटिंग नेस्टेड
हाँ
लूप अगेन
तो
एंड
मुझे
अगेन।
हाँ तो मुझे ट्राई करके दिखाना, भेजना मेरे को कोड।
मैम कर लिया।
तो दिखाओ।
हमें एक सेकेंड।
Okay, rest of the students, meanwhile, write your numbers in the chat. Thank you all for attending the session. Okay, तुषार explain करना। हाँ
मैम कर रहे हैं। तो मैम लाइन 12 में लिखा हुआ है।
तुषार, दो डिवाइस में से किसी एक डिवाइस को म्यूट कर दो।